Time, a concept so familiar yet profoundly mysterious, permeates every aspect of our lives. From the moment we wake up to the point we fall asleep, we are bound by its relentless march. Philosophers and scientists have pondered the nature of time for centuries, often arriving at different conclusions. While time may seem straightforward, measured by clocks and calendars, underneath this simple facade lies a complex and often contradictory reality. In our journey to understand time, we will examine how humans perceive it, how it's encoded in the brain, and its representation in physics through concepts like relativity and quantum mechanics. Let's embark on this intellectual exploration of one of the most fundamental yet enigmatic aspects of human experience. Humans experience time as a continuous flow, but this perception is a complex psychological phenomenon influenced by various factors. Attention, emotions, and memories play crucial roles in how we perceive time. For instance, periods of high emotional intensity, such as fear or joy, can alter our sense of time, making moments seem to stretch or shrink. When we are deeply focused on a task, time can seem to pass by quickly, a phenomenon often referred to as time flying. Conversely, when we are bored or waiting, time seems to drag on endlessly. Memory also plays a pivotal role in how we perceive time. Our recollections of past events can often influence our perception of how quickly or slowly time passed. This discrepancy between experienced and remembered time adds another layer of complexity to our understanding of time perception. Exploring these psychological aspects of time perception not only helps us understand the human condition, but also challenges the notion of time as a mere chronological measure. The human brain is a sophisticated organ that plays a central role in our perception of time. Specific brain regions and neural pathways are involved in processing temporal information, highlighting time's integral role in our cognitive functions. The frontal and parietal lobes, for instance, are crucial for the subjective experience of time. Neuroscientific studies have identified the suprachiasmatic nucleus, or SCN, in the hypothalamus as a critical area for regulating circadian rhythms, which are our internal biological clocks. These rhythms influence our sleep-wake cycles, hormone release, and many other physiological processes. Moreover, the cerebellum and basal ganglia are involved in the processing of shorter time intervals, crucial for tasks requiring precise timing, such as speaking or playing a musical instrument. Understanding these neural mechanisms not only sheds light on how we perceive and experience time, but also has practical implications. Circadian rhythms, the natural cycles of physical, mental, and behavioral changes that follow a roughly 24-hour cycle, are a profound demonstration of time's physical presence in our lives. Governed by the brain's suprachiasmatic nucleus, these rhythms dictate our sleep patterns, feeding behavior, hormone production, and other bodily functions. These rhythms are not just internal, they are also influenced by external cues like light and temperature, aligning our biological functions with the day-night cycle of our environment. This alignment is crucial for our overall health, as disruptions in circadian rhythms have been linked to various health issues, including sleep disorders, depression, and obesity. Plants, animals, and even microbes exhibit similar rhythms, suggesting that circadian timing is a universal feature evolved to optimize survival and reproduction in a cyclic environment. By adhering to these natural cycles, organisms, including humans, enhance their adaptability and efficiency, demonstrating time's critical role in the biological domain. Time's existence extends beyond our perceptions and biological processes. It is a fundamental aspect of the physical universe. Changes in the environment, such as the aging of living organisms and the erosion of mountains, are testaments to time's relentless forward march. These changes are not merely observations, but are underpinned by physical laws, such as thermodynamics, which describe the direction of time from past to future through the concept of entropy. The thermodynamic arrow of time states that in an isolated system, entropy, or the measure of disorder, always increases. This principle is what gives time its directionality, and is why we can remember the past but not the future. Moreover, time influences all physical processes at the most fundamental level, from the decay of radioactive elements to the rhythms of the planets in their orbits. This universality of time across different scales of existence, from atomic to cosmic, highlights its integral role in the laws that govern the universe. Time, therefore, is not merely a backdrop for events, It is an active participant in the unfolding of the universe. Albert Einstein's theory of relativity revolutionized our understanding of time, introducing the concept that time is not absolute but relative. His special theory of relativity posited that time slows down or speeds up depending on how fast one is moving relative to something else. This phenomenon, known as time dilation, suggests that time is intertwined with the fabric of space. Time dilation has practical implications in technology, such as GPS satellites. These satellites require precise adjustments to ensure accurate timing mechanisms. Einstein's general theory of relativity shows how massive objects can distort space-time, affecting the flow of time. The question of whether the past and future exist is a major philosophical and scientific dilemma. Common sense suggests that the past has happened and the future is yet to come. However, from a physical standpoint, particularly in the framework of Einstein's theory of relativity, all moments, past, present, and future, could theoretically exist simultaneously. This concept, known as block universe theory, posits that time is an illusion and that events are laid out in a four-dimensional space-time continuum. Philosophically, this raises profound questions about free will and determinism. If the future already exists, to what extent are our actions predetermined? One of the most significant challenges in modern physics is the reconciliation of quantum mechanics and general relativity, particularly their differing interpretations of time. Quantum mechanics, which deals with the universe at the smallest scales, describes time as a background parameter, a fixed stage upon which particles interact. In contrast, general relativity, governing the cosmos at large scales, treats time as dynamic and malleable, profoundly influenced by matter and energy. This discrepancy presents a fundamental problem. How can time be both an immutable backdrop and a flexible fabric? Efforts to develop a theory of quantum gravity, which would unify these two pillars of modern physics, have been central to resolving this issue. Exploring these conflicts and potential resolutions not only advances our understanding of the universe, but also pushes the boundaries of how we conceptualize time. While the physical and philosophical aspects of time are deeply complex, its practical necessity for human society is undeniable. Time as a concept likely emerged from the need to organize and synchronize human activities. From ancient sundials to atomic clocks, the measurement of time has been crucial for agriculture, navigation, industry, and almost every aspect of human endeavor. This necessity for coordination could be seen as a primary driver behind the invention of timekeeping devices. The calendar, another time-related invention, enabled societies to plan agricultural activities, religious festivals, and governmental functions, illustrating time's role in structuring human life. Reflecting on why humans invented the concept of time thus offers insights not only into our history, but also into our present-day values and challenges. It underscores the practical and existential dimensions of time, highlighting its role as a foundational element of human culture and consciousness. Time's influence extends well beyond scientific theories and philosophical debates. It is a central element of our daily lives and societal structures. In the practical sense, time allows for the coordination of activities, helping societies function smoothly. On a personal level, time helps structure our experiences, memories, and future plans, playing a critical role in shaping our identity and personal narrative. In science, time is indispensable as a measure that allows us to understand and predict natural phenomena. From the orbits of planets to the vibrations of atoms, time is a fundamental unit in equations that describe the universe. Moreover, time's role in the legal and economic frameworks cannot be understated. Contracts, work hours, and deadlines are all governed by the measurement of time, underscoring its importance in maintaining order and fairness in society. Recognizing and appreciating this duality, time as both a concept and a concrete measure, is crucial in understanding its overall significance. Time is a multifaceted concept that plays a critical role in both our personal lives and the broader universe. Whether viewed as a physical reality, a cognitive construct, or a necessary tool for societal organization, time's influence is pervasive and profound. The complexities in our understanding of time challenge us to think deeply about existence. In science, research into the nature of time, from quantum mechanics to cosmology, challenges our perceptions. In daily life, Time structures our experiences and decisions. From routines to milestones, time is a constant measure of existence. Embracing both the enigmatic and everyday aspects of time helps us appreciate its role in shaping the cosmos and human experience.